model to practical use. Let's suppose we have a common emitter circuit with a single power supply. And the reason I'm saying that is because later on we're going to look at one with a dual power supply. Okay, so here's one with a single power supply. Let's say we have VCC here. Let's say we have RC right here. Here is our transistor. So you have the collector, base, emitter here. And let's say we have RE, but we're going to bypass it in this manner in AC. And let's say we have R1, R2, so a voltage divider. Okay. And that would be R1, R2, and then a coupling capacitor for the AC input, right? So here he is. And then a coupling capacitor to connect to the load for the circuit. And let's call this one RL. So the key is, what is the equivalent? Or how do you redraw this in AC? Okay, including the pi model for the transistor. Okay, so remember that in AC, this ground here and VCC are all ground as far as it's concerned. So it's the same potential. So let's start with our source to ground. And let's look at this point here, from here to here. Well, what is that? Well, that's a short. So a coupling capacitor, right? A coupling capacitor will be shorted at certain frequencies. So assuming we are at the operating frequency, in which any voltage drop here in AC will be minimal, which means the impedance at that level is minimal. We have, from this point to ground, we have R2. So still there. And then we're still at that same point right here, right? R1, again, this becomes the same reference as this, as the ground. So that's R1 and R2 are in parallel. Okay? As far as AC is concerned, we're still, all of this here is the same potential as this whole line right here. All of this right here. Okay, so now we're at the base of the transistor. But remember, we're going to be using the pi model. And if you're going to be doing the pi model, let me just remind you what a pi model looked like. So we did this, and then the emitter right here. This was the base. This was beta RE prime, right? So beta times RE prime for the input, or Zn, the input impedance. And we had a current generator here with IC lowercase, and here's our collector, right? So this is what it looked like. It's not any different, except now the emitter is to ground, okay? Since this is a bypass capacitor, let's call it CE here, right? So this here, at certain frequency, whatever you picked as your operating frequency, hopefully that's what you intend to do. So that means you are shorting RE. But so what do you have there? So that's for the DC part of your circuitry as far as the QS endpoint. So that's where it's for. Okay. So all right. So that means at B, at the transistor, I still have this resistor right here to ground, since this is going to be ground for this circuit. So we're going to have, when I say ground, it's simply a reference. So beta, little RE prime right there. Okay. Now notice here, I'm not drawing any further. I'm not drawing a line any further, right? We're going to leave a gap because now we need to worry about the collector. So remember, this is the emitter right here. Okay. And then we have the collector, okay, which is a totally different model. So this isn't a physical circuit. This is a model. So what do we have if this is ground? Well, you have the current generator pointing down to ground in this manner. okay? And that would be little IC. Now, this is also equal to beta little IB, right? So if you have IB going through here, there is a relationship between these two. What else? Well, we have from the collector, this point right here, this point right here, and this point, remember this is ground in AC, well, that takes RC to be what? In parallel with that current supply. So this would be RC. Remember this transistor here is, again, a coupling capacitor to the next stage. Our next stage happens to be a load. So technically speaking, in AC, this is a straight line, which means a short. So that means from the collector, you're going to go to this ground through RL. So you're going to have RL in parallel. Okay? So this would be the equivalent circuit in AC for this common emitter. In the next video, we will investigate a similar circuit, but with a dual power supply, which means with a plus VCC and a minus VEE. I will see you then.